Welcome. Let's look at inverse trig functions. In particular, we're going to study the sine x function right now first, or you can think of it as sine theta. It really doesn't matter which way you call it on it. So let's do a quick, simple little drawing here. I'm going to call this negative pi over 2 and pi over 2. And here's pi, negative pi, and pi. Okay. And the graph, let's get this right here. The graph of the cosine or the sine function. I'm going to get right. Here's the basic sine function. If we went to 2 pi, we'd be going over to here and so on. So we can go, that's the basic sine x function. The inverse of it, well, we're going to go back once again, just like we have in the past, of finding using the y equals x line. So we'll do that in green here, y equals x. That parent function of linear equations is also the inverse line, or the one that we flip over. So what would happen here is that we would do just like going this way. And that last part was not drawing well. Sorry, nobody gives me awards for drawing, but you can get the idea here. So the idea here is that every point here has a matching point, essentially 90 degrees, because this one's going to come back up here, right angle, and I didn't draw it very well. This should have gone farther that way. But they are opposites flipped over y equals x. And that's what the inverse function looks like. The red one is the inverse function. Now, it will, and so actually, let's draw it down on here. Okay. So let me make sure I get it in the right way. What we're going to look at next, though, is that if you notice, this one's not a function right now. The blue one, the main one, is a function because at every point that I would draw a line, it only cuts through one time through that sine x function. Okay. So on the other side, though, if I were to do the vertical line test here, I'm cutting through it 3 different times. 1, 2, 3, 1, 2, 3. Anytime I cut it or go through it. So the vertical line test says it fails as a function. It is the inverse function, but it fails as a function. That's why down here we have to talk about a restricted domain. So when I look at this, if I take this part alone and only that part, it would still be a function. So I'm going to come down here and actually now let's put them next to each other. And so there is the inverse sine function. Okay, so I'm going to write y equals sine minus 1 x. But then over here, I'm going to write y equals capital S sine minus 1x. That capital letter designates that there's a restricted domain, a very specific one. I'll go over that in the next little part. But it means that we're only, in this case, I think it's about here to about here. And that part is the only part which would be from pi over 2 to pi over 2. And, well, negative pi over 2 to pi over 2. And that's the only part that can be used and still called a function. So in this case, instead of y, I'll say f of x. But is designated with a capital S, and it means only part of the inverse. Because if I went any farther, I would now be I'd be failing the vertical line test. And I would have more than one result for each x value. Now, down here, the restricted domain, think about where these, what will happen for cosine. Cosine, because, oh no, for sine, let's do sine first. For sine here, sine is acceptable, or the inverse of the sine function is acceptable between these points, from negative pi over 2 to pi over 2. Well, this one here that's 270 degrees is also negative 90 degrees, which is negative pi over 2. And up here, where we're at 90 degrees, is pi over 2. So this part here, is sine minus 1 of x or of theta. That's acceptable here in all of this area. And that's why, is because on the graph of it, it's the actual graph only goes from negative 90 to 90. So we either say negative 90 to 90, or we say negative pi over 2 to pi over 2. Right. So we would actually say sine minus 1, or domain of sine minus 1 of theta, is from negative 90 degrees less than or equal to theta, less than or equal to 100. Oh, I don't know why I'm putting 180 because I'm putting the next one. Whereas now let's use cosine minus 1. So cosines separable all through here. So the second and the first quadrant. So that means we're going from 0 degrees to 180 degrees, or 0 pi, just 0, to pi. So we would say from 0 less than or theta less than or equal to theta, less than or equal to 180 degrees. This one I'll say also less than or equal to pi. I should do the same thing for the sine up here. Negative pi over 2 less than or equal to theta, less than or equal to pi over 2. And then the tangent is the same as the sine. So it's just something to be aware of now, is the tangent uses the same one. So and that's because if you think about how tangent is graphed, let's get it where it's like this. When you flip it the other way, you're going to have, again, the same kind of problem with sine. So you need to, where only part of it can be used, or else you're going to have a non-function. So for a tangent, we use the exact same one. If it is the same. And negative 90 degrees. So do it both ways here. Now, notice in actual, I made the mistake here of not making a capital T. So let's do that. These are all capitals. Okay? Tangent minus 1. So a capital T, a capital S, capital C, designating that has a restricted domain. And we'll actually look at this here. Let's go over to here. And there is the sine curve. When I click on this, you see that it's a limited or restricted domain. It doesn't show the capital S here because Desmos doesn't work like that. If I try to make that a capital, it thinks it's doing something different. So I had to just put that in. But part of the understanding is an inverse function. Well, you have to assume the restricted domain. So notice that's only part of it there, like I did on the other paper. And in fact, we'll go back down to that. So, like I did here. So that's what it means to have an inverse function. You're just flipping it over y equals x, like we've done with other things. But there's a limitation. It cannot be a function if you use the whole thing. So you can only use part of it. And the domain itself is shown through this kind of almost chart that I made. And based on this graph here, that sine and tangent are perfectly fine here, cosine here, first and second quadrant. Now let's look at the next page here. Okay. Already in the past, you've learned to use the sine -1 key or cosine -1 or tangent -1 in order to get the angle or the amount of the sine. And to some extent, that's what we're going to do again here. So in a way, that's finding the inverse. It's like the inverse of the sine of the amount of a sine is its angle. So in this case, if I put sine -1.5 into the calculator, or if I look on the unit circle, I would see now that there are actually two places for this. So in this case, I would get a 30 degrees. I think I'll put that in blue. On the unit circle, we see 30 degrees and we see 150 degrees. But on that unit circle, 30 is here and 150 is here. So what 150, the sine is 1/2. However, remember that the sine can only be, the inverse sine can only use the first and fourth quadrants. That makes 150 an extraneous answer. So we can write the answer as 30 degrees, or we can write it as the radian form, pi/6. When we see arcsine, that means the same thing. I should have made that a capital A on there. I'll do that now. So arcsine is the same meaning as sine -1. Same, which means that it's going to be also 30 degrees or pi/6 if you wish to call it that. Those are on the unit circle and easy to see that way. If you have a different one where it's not on the unit circle, you would use the calculator for that. Okay, so I just realized I forgot to put the -1 on here. Oh, no, wait a minute, don't do that yet. What I do is, since the sine of the angle is 0.8, I would then say sine -1 of 0.8. That's going to equal our angle. And for this, for decimal ones that are not on the unit circle, use a calculator. If not on unit circle. Okay. So when you put this into the calculator, you get that sine -1 of 0.8 is equal to 53.13, which is 53 degrees. Or approximately, there we are, 53 degrees. Now, let's look down at combinations. For combinations, let's just do steps. So we're going to do step 1. Step 1. So we have to do cosine -1 of 1/2. So I'm going to write cosine again, but now instead of sine -1 of 1/2, we figured out that that's 30 degrees or pi/6, whichever one you would call it. I'll stick with the degrees. So that's cosine of 30 degrees. Well, then cosine 30 degrees, just look at the unit circle, and that means it's square root of 3/2. So it's first finding the angle. This is hiding what the angle is here. You get the angle, and then the cosine of that angle, that's what you're looking for. So now we do that here with tangent, and we think for cosine -1, where is the cosine square root of 2/2? Well, it's in two places, 45 degrees and 315 degrees. But for tangent, in fact, I'll make my circle again. 45 is here, and 315 is here. For cosine, 315 doesn't work because cosine is with a capital C. The inverse for the cosine or the angle or the inverse, you have to use this here. So that means what we now have is the tangent of 45 degrees because square root of 2/2 is the x value at 45 degrees. Over here, it's a negative. At this point, 135 It can't be that because it's a negative root 2 over 2. So we now know that instead of this, we can write 45 degrees. And the tangent of 45 degrees is 1 because we have y over x. Tangent of theta is equal to y over x, which is equal to square root of 2 over 2 over square root of 2 over 2. Well, interesting. If you have a fraction of one thing over the exact same thing, that means it's equal to 1. And that's how we get this 1 here. So if you recognize what's happening where you're just finding the angle first and then using the other thing with that angle, see it as like two separate problems. This is one of the easier things to do. Let's get all that back. So I want to emphasize which ones are the right answers here. And that's why I'll do the 5 degrees and the 30 and the 30. So this first page was explaining the concept and having you see it and recognize then the domain, the issues of the domain. And then seeing the notation with sine minus 1 or arc sine, and simply getting the angle, or using a calculator if appropriate, if it's not underneath the circle. And the combinations where we do a step 1 and then a step 2. And step 1 is getting the angle, as you see in these two examples. And then step 2 would be using the cosine or using the tangent. Well, I hope that helps. Thank you for watching and for listening.